Assalamu alaikum warahmatullahi wabarakatuh. We are just going to continue over the last lesson, that was lecture 8, and we are discussing quadric surfaces in that one. In last lecture we have already discussed this ellipsoid, hyperboloid one sheet and hyperboloid two sheet, and today we are going to continue with cone and elliptic paraboloid, and we'll discuss also the hyperbolic paraboloid. So these are the things we are going to discuss. We have seen it that in this ellipsoid we are having all the values here are positive, and here we get here negative, one negative. We say hyperboloid of one sheet. Then we having here two negatives here. Also this is negative and this negative. And two signs are negative. One is positive. We say is hyperboloid of two sheet. We have seen that one. This we can make from one sheet, and this we have, as discussed, there is an area where we don't have the graph and we have to need two sheets for that one. So if I just sketch it very quickly and just give you the idea of that one. Here where C is bigger than our A and B, and this is my x-axis, and this is my y-axis, and this is my z-axis, and here I have this one. So my ellipsoid is this one. This is my z plane, and here I get my x y plane. This is passing through this my y, and here is my x z plane, and then here I having xy plane. So this is my ellipsoid, and then I have the hyperboloid of one sheet, as I mentioned here. This is, we get here hyperboloid of one sheet. However, I have two sheets. If I just take it opening from the z-axis, so this is the graph of that one. Here we get the graph like this one, and there is no graph between this value of z. There is no graph to my z-axis, and this my y-axis, and this my x-axis. So I just make it quick idea for that one. So next is our cone. You can see it here. We having the hyperboloid of one sheet. If we put this equal to 0, that becomes the cone, and we know the cone in our life. This ice cream cone. That's the idea for that one. So similar to that, we can have the cone in this one. Then when we are discussing the quadric surfaces, we try to get the trace. We get the equation of the trace, and we try to find the graph for that one. So name a equation of the trace, and then we just have the sketch of that one. We can draw the quadric surface for that. So we are having this example. Actually, I'm just taking this as a cone as an example, because I have just generalized this one ellipsoid paraboloid of hyperboloid of one sheet and two sheet. We take particular example. We have the value of A, B, and C here. Our A is 9, our B is 4, and C is 6, and this is having 0 on the right hand side. So this is just like here in 4, we say this is the cone. The surface is the cone. So this is part 1 that we want to say what's the surfaces. This here is number 1. Number 2, we go to the traces, and we say we take the trace on the coordinate plane, and then we are having the equation of the trace, and then we describe or say name of the trace. So we can see it here. We take x equal to 0. When we take x equal to 0, we get the equation y square over 4 minus z square over 4 equal to 0. Then we take here this my in yz plane. This is here we say it's in yz plane. This is part number 1. Number 2, y equal to 0. This is xz plane. And in xz plane, we'll get here y equal to 0. That give me y equal to 0. That get here x square over 9 minus z square over 4, and that's equal to 0. Then number 3, I take z equal to 0. I get here xy plane, and in xy plane I can see we can having here x square over in y square 9 plus y square over 4 is equal to 0. So what is described that we want to see it here. This is describing here. If you take the number 1, we're having y square over 4 minus z square over 4 equal to 0. I will say here y square over 4 is equal to z square over 4. I can say y square is equal to z square. I will take root of this one, then y is equal to plus minus z. That's y is equal to plus z, and y equal to minus z. In yz plane, we can see that these are our intersecting line. So we say this represent our line is y is equal to plus minus z, and these are our intersecting line. So we get here two lines, they are intersecting each other. So similar to this one, if I take here x square by 9 is equal to z square by 4, and where x square is equal to 9 by 4, z square, take the root, x is equal to plus minus 3 over 2 z. So we say y x is equal to plus minus 3 over 2 z. Again, they are intersecting line. We get here intersecting lines. Also, we get in xz plane. Now, when we take here xy plane, then get here x square over 4 is equal to minus y square over 9. We get here x square is equal to minus 4 over x square over 9, y square over 4. So we get here 9 over 4 y square. We take root of this one is not real. So we don't have any graph at this point when it takes z equal to 0. Now when you take here x equal to y equal to 0, then we can have here z equal to 0, y equal to 0. This implies x equal to 0. That means we'll get here the graph will be 0, 0, 0 is origin. That's the graph we'll get here from this one. But there is one question which arises, that if we are having here the value of z not equal to 0, but any value of z, it can be plus or it can be minus. For example, I take here z equal to plus minus 1. I take it to z equal to, because square, always z square will be equal to 1, it's plus or minus. So I have the equation x square upon a square, that's x square upon 9 plus y square upon 4, and we have taken our z to the other side. We get here z square over 4. I take z equal to plus minus 2, so I get here 1. So I can take it here any value. Here is z is bigger than 0 or less than 0. We say absolute value of z. We take any value of z here. We take absolute value of z is bigger than 0. It can be, z can be positive and z can be negative. We'll have the graph. As we see, when take z equal to, what I'll get here, we get here x square over 9 plus y square over 4 is equal to 1. And this is what? This is our ellipse. So we have the graph ellipse when z equal to 2 or z equal to minus 2. So it means for each value of z bigger than 0, we get here the ellipses. We have z equal to 1, z equal to 2, z equal to 3, z equal to minus 1, z equal to whatever we write, we get the ellipses. So these are the ideas we got it in this example, that for the cone we take this equation. Again, we having one negative sign, that means cone, right hand side is 0. Then number 2, traces. When take x equal to 0, this is our intersecting line, y equal to 0, intersecting line, z equal to 0, we don't get any graph, because we get here this only one graph, that value, that is when you take y equal to 0, and we get here x equal to 0, that's a graph. Now I sketch this one. I have here as my z-axis, this is my y-axis, this is my z-axis. So what's the graph in this one, yz plane? Yz plane, the graph is intersecting line, y equal to z. This is making angle of 45 degree here. This is the line y, z equal to y or y equal to z, both way it is correct. And here is the line, this is my origin, y equal to minus z. So you can see it here. This is my here, this is the intersecting line. Two intersecting lines, is number 1. Number 2, y equal to the xz plane. We take here xz plane. This is my x-axis. I just sketch this one, my x-axis. This is my x-axis. This negative side my x-axis. This is my z-axis. So I am having here the graph like this one. This parallel to x-axis. This one, and then I am having the lines which are passing through the origin. This is the line here. This is y equal to minus 3 by 2 z, and here y is equal to plus 3 by 2 z. This is my lines that I get here, and this is my graph for that one. So this is my intersecting line is equal to x equal to 3 by 2 z, and here x is equal to minus 3 by 2 z. Now our graph for z equal to 0, that's the origin. This is my origin. Then we can see when x is bigger than 0, x equal to 2, we say here this is z equal to 1, this is z equal to 2. So z equal to 2, we are having the graph in xy plane. So this is my x-axis. This is my x-axis, and no, I don't have this one. This is my xy plane, and my y is this here, and like this one, this will give coming like this one here, and this is the graph for my this one, z equal to 1, z equal to 2, then xz plane, this here coming like this. Now these values, what we get here in this case, as we mentioned, that here we get the ellipses. This is an ellipse in xy plane. This is an ellipse in xy plane. This is an ellipse in xy plane. This is an ellipse in xy plane, and so on. This is an ellipse here. The xy plane, this is my x-axis cutting here, and then this is my y-axis cutting here. This is my x-axis here, and y-axis, this is my x-axis, and here is my y-axis, and I can get here also. The graph is like this. This is my x-axis, and this is my y-axis. So this is the picture which I'm getting like this. If I just sketch it more clearly, and we are having here this sketch will be like this one, and this sketch we call this one as a cone. This is my cone. So this is the graph for my cone, and we're having the equation for this one. As I mentioned, that we are having here the value of one of the sign is minus, and the other side is 0, is opening upward where the minus sign is. So it can be here, it can be here. Only the question is one of them is minus. So this is the idea that we are having here, this cone, and I just give you an example to explain this one.